Welcome to the next episode in our software modernisation series. Today we're joined by Steve, who's Codurance's UK South Regional Director. Welcome, Steve. So previously we've discussed the drivers and the challenges and the methods in how to align your organisation to get buy-in for your modernisation strategy. And then in the previous episode, we talked about how to get started, how to organise your teams, and the skills you would need within that team to approach and implement your strategy. So today we're going to open the discussion on the different technical strategies to make your software easier to maintain. So with that in mind, let's open the conversation up.
Right, so there are different types of strategies. The very conventional one, for example, I saw a lot of very simplified ways of describing those strategies. And the simplified version is always like, oh, there is a rewrite, or there is a re-platform, or there is a re-architect, or a refactor, and things like that. So although this helps you to talk about the distinction of those different strategies, in practice, what we experience is that most software modernization programs is a combination of all of that. So first, there is a combination of those different things of rewrite, re-platform, re-architects, refactoring. So it's more of a hybrid, but there's also different levels of abstraction where we apply that. You can apply that at a very, very high level, enterprise architecture, all the way down to a specific area of a specific system, right? So I know that Mash and Steve have far more experience than me, like on the more, well, maybe we could start from the high level and talk about some of the re-platforming or re-architecture at the wider level. That's probably a good place to start, and then we can start going down.
Yeah, I think the reason it is very much more subtle than that is that you don't look at re-platform, re-architect, and so on at the overall system level, right? It's always parts of the system that require different aspects of the strategy. So before you actually, I mean, one way to come into this kind of technical strategy for software modernization is to look at a higher level on what's commodity, what basically things that everyone else, the problems that everyone else has, and what's core to your business, right? So there's one of the exercises, for example, we do with our clients is Wordly mapping, to try to understand exactly what is commodity and what's core to their business, and even chart a path to using commodity platforms and software for that commodity aspects of the business, right? Part of the same exercise is actually trying to understand what are the functional areas in your business, because often when systems are built, they are kind of built as almost like a monolith, and it's normally the reason being that things have evolved and evolved different ways, and there's almost been a kind of an add-on and another add-on, and on top of that another add-on, and so the system is not really in a coherent state. You know, everything is everywhere almost. And so you're trying to create these functional areas or bounded contexts, and context mapping from domain-driven design is another exercise that you can do to try to understand what are these different functional areas, and from there you can try to understand what are the commodities and what's core to your business, and from there you can start then looking at how you kind of move the commodities, and the commodity could be related to using online software as a service platforms, could be related to using cloud native technologies and so on. And platform is often a major commodity unless you are in either a unicorn like Facebook or something, or into the business of creating platforms. Is usually a commodity. So that's another area that we look at, and moving those things towards what we often call a more kind of cloud native or a SaaS type offerings.
Mm-hmm. And certainly some of the clients I've worked with, it's It's not just a matter of modernizing the software itself, the application, whatever that a particular client works on, but it's also often a huge job to modernize the platform engineering behind it, right? So particularly, I've certainly worked with some clients who've written their own platform engineering, their own deployment pipelines, etc., with outside of tools, so their own scripted, written in code, and these people really struggle to maintain the pace of change of the cloud. When they were going to their own tin and in their own data centers, it was quite easy to keep on top of these things. But there's something definitely to be considered, that you probably want to have better tooling in place that's able to change along with the pace of change as you move to a more modern platform as well.
And I've seen, for example, clients that are trying to move to the cloud, right? So a lot of them have already, depending on where you are, certain regions are more, how can I say, they are at a different stage than others. So, but I've seen a lot of cloud migrations, let's say, that they were able to just put their application into a container, and then they are using the cloud as almost like a glorified data center. They just have virtual machines into the cloud, but they are not really re-architecting. So they are re-platforming, but they are not re-architecting the applications to actually use the potential of the cloud, right? So we were talking about here scalability, we're talking about security, we're talking about a lot of the observability of the system in the production environment. So I believe that, as Mash was saying, the cloud native could help to cater for that without us having to do that in the software itself, right?
Yeah, totally. And actually relying on kind of more, not like, of course, the basic thing that you can have is a VM, right? And then everything runs on a VM, so you can have your own messaging, you can have your own kind of ways of deploying, you can have your own, even deploy your own databases, right? But when you really start leveraging the cloud technology, when you kind of lean on the services that they provide, so that you don't have to maintain and operate it. Of course, there is a cost associated with that as well. But generally, although kind of per transaction cost may get higher, but when you bring in everything else that needs to be done to maintain it, and the time that you will lose concentrating on that aspect, it ends up being almost a no-brainer to start using some of these offerings. But of course, that has quite a big impact on how you architect the application as well. So an application that is designed to be run on VMs, for example, may not necessarily translate to now something that can have some parts running on, containerized kind of clusters, and some parts running on SaaS kind of message-based offerings, and even the databases. Often there is, classical applications have a big database sitting in the middle, normally a relational database, right? And of course, cloud offering provide relational databases, but they provide lots of other alternatives as well. And this goes back to architecting the application so that it leverages the technology that is best suited to the needs of that part, right? And so you kind of have almost like a mini architectures amongst a wider architecture, right? And you are even leveraging the cloud in the sense where, for example, you don't have let's talk about serverless, for example, right? It's suited to a particular need where, if your transactions are, let's say, not as frequent, then this is an area that, leveraging that part could actually help you reduce costs and even simplify the overall application.
Yeah, I'm hearing a few different strategies coming up. I'm just, I really like the point you said, Mash, about, you get in the architecture, you lift the bonnet up and there's an add-on and an add-on. It's almost like you're describing, definitely some of the previous projects that I've worked on. So what I'm hearing is by doing that upfront design work and applying some of those approaches helps you understand as an organization what is the best strategy for you, and it's that kind of bespoke element in terms of the problem you're trying to solve or the opportunity that you're working towards.
It also depends on the size of the estate that you want to move in total. So if you have a very large on-premise traditional data center estate that you want to move to the cloud, this can be a huge project that can take many years. And I think that part of your consideration for the architecture needs to be that transition period when you're probably working partly in the cloud and partly on premise. And we see a lot of challenges, particularly around security in this area. And it's relatively easy to go from an on-premise data center to the cloud, but to go from the cloud onto an on-premise data center can often have quite a lot of security implications. So you really need to make sure that we don't just consider the end state, but we consider, how we're going to move to that over the next few years and remain operational and not sit in a room somewhere and go for a big bang release in 2 years' time.
And part of that is also, I love this concept of there are certain things that you can do along this evolution, which are kind of force multipliers, right? So some things that you can do, and I think you alluded to it earlier as well, is that can help you do other things faster or the other aspects of this evolution faster. So getting the platform right, and I think we're kind of banging that drum a bit, but getting the platform right in the beginning or towards the kind of the first part of this effort can actually multiply the effects of your efforts moving forward, right? So it's important not only kind of doing it in an evolutionary way and making sure that the business as usual goes along with it, and you're not kind of building something on the side. But the other thing is, it's also interesting to decide exactly what parts are you going to do. We talked about this earlier as well. There's one alignment with the business, and you need to make changes on where the business wants to make changes. But the other thing is that these force multipliers at the platform level that can actually help you make those changes quicker.
As we said quite a few times, like, it's really important to keep focus on the problems that you want to solve, right? And we have like a very concrete example of a very large client of ours where their modernization strategy touches upon all of those things in terms of there are bits that we are rewriting, there are bits that we are replatforming certain aspects. We had to re-architect other areas, and we are doing a lot of refactorings. But like, for example, in this context, what they have is they are in a regulated environment. So their production environment, they need to be a multi-instance. They cannot be multi-tenant, which means that most of their, each one of their clients, they need to have their own production environment. So pushing that to the cloud and using the cloud automation allows us to recreate those environments, because we are talking about thousands of clients where each one has its own environment. But not everything is multi-instance, because certain clients that are the main software, the clients, they need to have their own system, their own databases and stuff, of course, because if one goes down for whatever reason, it doesn't impact the entire healthcare system of the United States, right? So but there are many things that happens in the background that are shared services that all of those different systems, they talk to, and they have completely different demands in terms of scalability, in terms of performance, in terms of volume of data that they use, and they can benefit from a completely different type of architecture. In terms to benefit from outscaling, from security, from all the load balance. And even, for example, we were discussing, if the application is stateful, the application was built where they hold state between requests, it makes it much harder to scale.
Yeah.
right? So I think it's interesting to see like what kind of problems we are trying to solve and where, because you can combine multiple strategies of architecture depending on which problems you were trying to solve. So we are talking a lot about more like at the enterprise level, at cloud and stuff. But there are many other problems that are common in modernization projects that, for example, they have teams that are there are hotspots in the code where everyone is multiple teams. There's a high contention because the teams, they need to coordinate or they need to talk too much to each other. They write one thing, they break the other. It's also, we were in areas where parts of the system, they had to be compliant. Like we had a credit card process within the monolith, for example. But that area of the payments system, for example, they had to go through, they need to be PCI compliant, for example.
Right.
But that doesn't mean that the rest of the system, the catalogs, the user journeys and things like that needs to be PCI compliant, because that has nothing to do with that. So there are many different concerns that we can address at a lower level to break teams apart, testability, right? So we had quite a few experiences.
It's actually that's a really interesting case, because I remember when we looked at it, like said, okay, payment needs to be a separate thing, because when you make changes to payments, it has to go through PCI compliance kind of processes, but the rest of the application doesn't. But when we came to doing that, we actually realized that even within payments, there are two types of payments. One actually holds the credit card information, and the other one is just simply using payment gateways. And the payment gateway part does not require PCI compliance. So kind of like taking that split, and you split even further to say, well, okay, you got a payment kind of area that is for where we hold the credit cards information, and another area where we don't, which is just an integration to another payment gateway. So you kind of like taking that another perspective at a lower level or kind of almost a cross-functional perspective actually helps you divide things even more to enable change better.
Exactly, because the problem that we were trying to solve, we wanted to have more frequent releases. But in order to have more frequent releases, we had to apply the same strict process across the entire system. So when we are breaking our system apart, so depending on which problem you're trying to solve, you might end up with a different architecture strategy or design strategy in how you split your system apart. So then we could just isolate that piece that really needed a strict let's say auditing in order to be released from the rest, and then we can have a different release cadence and even a testing strategy for those things. So this is a slightly different approach to modularize, not only about functional areas, but as Mesh said, about compliance and things like that.
Really liking how we talk about breaking the problem down, not only in a approach, but then in implementing the change. And very much, one of the benefits for that is you could start to see the return on investment for those different areas. Sandro was just talking about, breaking particular areas down and testing that. And, so you're almost got areas that you can start to see the change in those metrics to know that you're moving in the right direction. And it's all really good kind of communication and data points for the rest of the organization that we've previously spoken about. We've taken on this journey and, we're aware of what the benefits are to the different parts of the organization through the changes. So it's really great kind of visualization to see the benefit of breaking down the problem and the approach. That's great.
I think it's a very important point, Amelia, is that like sometimes we forget that we know that these things make sense and we start doing them and we have that conviction that they are going to provide a lot of benefit. But actually we need to be more disciplined about gathering that data, right? So if we have a hypothesis, so for example, moving to a better platform would help us kind of make the releases faster, or moving this particular service out of, let's say, a monolith. Well, are we actually tracking our release frequency, for example? And what are the other kind of measures that we are taking along the way that are helping us understand that we are concentrating on the right thing.
I think another thing is to know when it's good enough.
Mm-hmm.
So because we can always make something fast, we can, but you need a kind of a realistic target, and at that point now we're good enough. Now that the effort and therefore the money should go into some other improvements.
Mm-hmm.
We need to know when to stop as well as what we're aiming at.
Yeah.
This is a fascinating thing because there is probably a tipping point where the amount of effort that you put on improvements stop paying off, right? Mm-hmm. So understanding that you don't need to change the whole world, and you don't need to have like everything absolutely perfect. First of all, that doesn't exist, right? So you cannot get there. There's always something to be improved, as you were saying, Steve. And then there is this mainly in the craftsmanship world where we talk about excellence all the time, right? And this is great because there is the focus on excellence, but unbounded excellence leads to waste, mm-hmm. right? Leads to a lot of effort that doesn't give benefits. So a constant discussion that we had, and I was trying to think like, how do you balance that, right? You want excellence, but until at where? So if you flip that around and say like, the excellence should always exist, but within boundaries. Boundaries of what? Probably bounded by a pragmatic solution. So, for example, if you look at your problems at a higher level, you define the boundaries of your solution. So, like, look, this is what we need to do. This is the boundaries. You're not going to do anything outside. That's what the remit of this work. So you define the boundaries in a very pragmatic way, and within those boundaries, you have excellence.
Yeah, it's really interesting because it's a system, right? By its very definition, everything is interlinked. So what do you move first? Because it's going to have an effect on every other part of the system, to some degree. So, if you decide to make a change somewhere, well, you have to bring everything along with it. Well, all of a sudden we're not, we're a long way from kind of incremental releases now. Mm-hmm. One small change can turn into a huge amount of work, and so you have to have that kind of pragmatism there and that kind of compromise.
As we were saying, there are quite a few problems that we want to solve, and the modernization efforts, the strategies that we create for modernizing something, is to actually solve a problem, right, or prepare the system to what is coming in the future. A common one is testability. That is one of the most common things that people come to us and say, look, and testability is normally coupled to the frequency of release as well. So normally those two are always come together. We want to release more often, but for that, we need to make sure that we trust what gets released, mm-hmm. right? And there are many different strategies that can be used for that. First of all, does the system need, for example, the amount of tests and the rigor of the tests, are they the same across the entire system, or there are a few areas where the rigor of the test and the amount of tests we should pay far more attention in certain mm-hmm. areas than in others. So understanding those things, and we already discussed about the compliance and stuff. So that is one area of isolation, but also understanding those critical areas of the system and being able to detach those areas from the rest. And detaching, I want to be clear here. It's not only about microservices. We mention microservices because it's a common approach. A lot of applications are web apps, and a lot of them are multi-tenant. Mm-hmm. So in cases like that, microservices normally work really well. But in cases where we cannot have multi-tenant, or you need to keep the monolith, the modularization aspect is still extremely relevant. You can modularize, because this is a misconception. Modularizing is not about microservices. Modularization can happen at many different levels. Mm-hmm. Right? Even the way that they're having different systems, full-blown systems full of features, is a aspect of modularization. It can go all the way down to classes and namespaces and packages that are also different degrees. But modernization normally is quite key to isolate areas. They will help testability, because as you modularize, you have a very clear boundary of that module and you can test those modules independently. It helps team work, because as you are scoping the work, you know which modules will be touched, and you can define a very you can have a well-defined interface between those modules, even at a very lower level, as I said, even at the class and package level, right? And it can help with continuous delivery as well, because you don't need potentially to release the entire thing. A lot of continuous delivery companies that are able to do continuous delivery, that doesn't mean that they release their entire platform together. They release bits and bobs, right? So normally, quite often, modularization is quite key in all the efforts.
Another element, the case for modularization is the kind of cognitive load, right? So we talk about what we can hold at a particular time. So if we are making change and we have to wade through a lot of irrelevant information to get to the relevant one, or keep more information in to be able to make the change kind of cohesive, then you've got a problem as well. There's an increased risk of making the wrong changes or making changes in the wrong place, So that's another area which kind of, again, across all kind of levels of abstraction is extremely important, all the way to teams, right? That, if you've got a team doing lots and lots of different things, like going back to platform, if the team is not only building the features, but also running the kind of building the platform and those kind of things, of course, their cognitive load is increased. And that goes down to the class level or even function or method level, right?
Yeah, and if you're able to lower the cognitive level, you'll get less bugs, right? If the code is really easy to understand, the people that are working on it, it's very well modularized. It does one thing, and the code is very obvious. Even if you don't have 100% test coverage, you're much less likely to have problems with that code. And this, I was going to mention this before on your last point as well, is if you are releasing modules independently of others, you need to be careful with that as well, that what those dependencies are, that where breaking changes are, that that you're managing backwards compatibility and versioning, etc., and this is definitely something that needs to be considered.
Well, this is the complexity you introduce in the with a microservices based approach, right? Nothing is free. You're moving a lot of the complexity from the from the compute into the integration layer, and that brings its own challenges. And if you don't do that well, then you may give yourself bigger problems than the ones that you're trying to solve.
Also really enjoyed the conversation today about the personalized approach at all levels of approach, and how the strategy for kind of making your software easier to kind of change is dependent at the level of abstraction, as well as those other factors we've talked about before, kind of the organization at hand, your own architecture, and what you're trying to achieve. So thank you very much.
Thank you.
Thank you.